Look up at the night sky. It's a canvas of endless wonders, a tapestry woven with the threads of time and space. Every star, every planet, every bit of dust and gas. It all came from somewhere. Each particle has a story, a history that stretches back to the very dawn of everything. The story of our universe is a story of incredible change, of unimaginable power, and of breathtaking beauty. It's a tale that spans billions of years, filled with moments of creation and destruction, of chaos and order. It's a story that begins with a single event, a moment of creation that echoed through the vastness of space and time, the Big Bang. This monumental explosion set the stage for everything that would follow. Imagine a universe so small it could fit in the palm of your hand. A universe that holds within it the potential for everything we know and everything we have yet to discover. Now imagine that tiny universe filled with unimaginable energy, an energy so intense it defies our understanding. This energy was the driving force behind the birth of our cosmos. This was the state of the universe 13.8 billion years ago, a singularity of infinite density and temperature poised on the brink of an extraordinary transformation. Then, in a fraction of a second, everything changed. The universe exploded outward, expanding at an incredible rate, a phenomenon we call cosmic inflation. The universe exploded outward, expanding at an incredible rate. Galaxies began to form, moving apart as space itself stretched and grew. Space itself stretched and cooled, carrying with it the seeds of everything we see around us today. The fundamental forces of nature began to take shape, guiding the formation of matter and energy. From this primordial soup of energy, our universe was born. It was a time of rapid change as particles collided and combined, forming the building blocks of everything we know. Our journey to understand our origins starts here at the very beginning. It's a journey that takes us back to the first moments of time, to the birth of the cosmos itself. It's a journey that will take us through swirling galaxies, across vast distances, and back to the very planet we call home. Along the way, we'll encounter the wonders of the universe, from the smallest particles to the largest structures. Join us as we explore the awe-inspiring story of our universe and uncover the secrets of how it all began. Together, we'll delve into the mysteries of the cosmos and seek to understand our place in this vast, ever-expanding universe. The Big Bang wasn't an explosion in the traditional sense. It wasn't a detonation that sent fragments flying into pre-existing space. There was no empty space for it to explode into. Instead, the Big Bang marked the sudden and dramatic expansion of space itself. Instead, it was the rapid expansion of space itself. Space didn't just expand, it stretched, carrying everything within it outward. Imagine a balloon with dots drawn on it. As the balloon inflates, the dots move farther apart, not because they are moving on their own, but because the surface of the balloon is expanding. As you blow into the balloon, the dots move farther apart. This is a simple analogy to help us visualize the complex nature of the universe's expansion. The universe expanded in much the same way, carrying galaxies along for the ride. Galaxies are not moving through space. Space itself is expanding, taking galaxies with it. In the first moments after the Big Bang, the universe was an inferno. Temperatures were so high that no atoms could form, and the universe was filled with a hot, dense plasma. Temperatures were unimaginably high, and energy crackled through the expanding cosmos. This energy was so intense that it prevented the formation of stable particles. It was a chaotic, turbulent environment, but within this chaos, the seeds of order were being sown. Tiny fluctuations in density would eventually lead to the formation of galaxies and stars. As the universe expanded, it cooled. This cooling process was crucial for the formation of the first particles and atoms. This cooling allowed energy to convert into matter and antimatter. Particles began to form, and the universe started to take shape. These particles constantly collided, annihilating each other in bursts of energy. This process was violent and energetic, but it was also essential for the evolution of the universe. But for some reason, a tiny fraction more matter was created than antimatter. This slight excess of matter over antimatter is one of the great mysteries of cosmology. This tiny imbalance was crucial. Without it, the universe as we know it would not exist. It's the reason we exist at all. This imbalance allowed matter to dominate, leading to the formation of stars, planets, and eventually life. Without it, the universe would be a sea of energy, devoid of stars, planets, and life. The delicate balance of matter and antimatter is what makes our existence possible. As the universe continued to cool, the surviving matter particles began to interact. These weren't the atoms we know today, but their fundamental building blocks, quarks and leptons. These particles, governed by the fundamental forces of nature, began to form the first elements. Protons and neutrons, made up of quarks, emerged from the cooling universe. Electrons, a type of lepton, zipped around, interacting with these newly formed particles. The stage was set for the creation of the first atoms. Around 380,000 years after the Big Bang, the universe cooled enough for electrons to be captured by protons. This capture formed the first atoms of hydrogen, the simplest and most abundant element in the universe. The universe, once a hot, opaque soup of particles, finally became transparent. Light could now travel freely, carrying with it the echoes of the Big Bang. We can still detect this faint afterglow today, a testament to the universe's fiery beginnings. The universe, now filled with hydrogen and a smattering of helium, was not uniform. Tiny fluctuations in density, remnants of the quantum world, were amplified by gravity. Gravity, the invisible force that draws matter together, began to sculpt the universe. In regions where matter was slightly denser, gravity pulled in more and more hydrogen gas. These clouds of gas grew denser and hotter, eventually reaching temperatures and pressures where nuclear fusion could occur. The first stars ignited, bathing the universe in light. Stars are the cosmic engines that create the elements necessary for life. Inside their fiery cores, hydrogen atoms fuse to form helium, releasing enormous amounts of energy. This energy is what makes stars shine. Over time, gravity gathered stars together, forming vast collections called galaxies. Our Milky Way galaxy, a swirling disk of billions of stars, is just one of trillions that populate the observable universe. About 4.6 billion years ago, in a quiet corner of the Milky Way galaxy, our own solar system began to form. A giant cloud of gas and dust, perhaps disturbed by the shockwave of a nearby supernova, began to collapse under its own gravity. As the cloud contracted, it started to spin faster and faster, just like a spinning figure skater pulling in their arms. This spinning motion caused the cloud to flatten into a rotating disk. At the center of this disk, gravity pulled most of the material inward, eventually forming our sun. The sun, a massive ball of burning hydrogen and helium, became the heart of our solar system, providing the necessary heat and light for the surrounding material to evolve. The remaining dust and gas in the disk didn't fall into the sun. Instead, they began to clump together due to electrostatic forces and gravity. These clumps grew larger and larger, sweeping up more and more material as they orbited the young sun. Over millions of years, these clumps became planets, including our own Earth. Our solar system wasn't always a peaceful place. The early solar system was a chaotic environment, with planetesimals, asteroids, and comets colliding with one another in a cosmic dance of destruction and creation. These collisions were not just random events. they played a crucial role in shaping the planets and moons we see today. The impacts caused by these collisions generated immense heat, leading to the melting and differentiation of planetary bodies. Over time, the molten Earth began to cool, forming a solid crust. Volcanic activity and outgassing released water vapor and other gases, creating an early atmosphere. This atmosphere was very different from what we breathe today, but it set the stage for the development of life. The early solar system continued to evolve, with the planets settling into their orbits and the remaining debris forming asteroids, comets, and other small bodies. The asteroid belt between Mars and Jupiter and the Kuiper belt beyond Neptune are remnants of this early period, providing clues to the processes that shaped our solar system. Today, our solar system is a stable and dynamic place, with each planet and moon following its own path around the Sun. The story of its formation is a testament to the incredible forces and processes that govern the universe. And while our solar system is just one of billions in the Milky Way, its formation story is a fascinating chapter in the grand narrative of the cosmos.